the type. Which type is this? Is it 1, 2, 3, or whatever?
3.
3 indeed. So this is indeed type 3. And I know immediately no horizontal asymptote, but slant asymptote must be found. I get my table going. Good. So what do we need to do first then? Anyone? How do we start? What is the starting point? Can anyone help? Michelle, what do you think?
Finding f prime, or oh no, finding the domain.
Excellent. Yes. What do I need to do with the denominator?
You just set it equal to 0. So
Right, but it's easier first to take a look at it, and then yes, we can set it equal to 0. I couldn't hear you.
I said x plus 1, x minus 1.
Very much easier now to say that x does not equal.
Negative 1, 1.
Very good. So of course I get back to the table. Negative 1, 0 in the middle, 1. You don't have to put 3. Maybe 1 is enough. I just want to make sure that it's clear. It's up to you. You can just write undefined. Create your own, whatever you want to do, as long as it's clear to everyone. Okay, good. So these two do not disappear. Because they don't disappear with a factor from the top, I will immediately write that x equals 1 and x equals 1 are what?
vertical numbers.
They holes in the graph.
X plus 1 was simplified, therefore x equals negative 1 is not a horizontal, is not a vertical asymptote, but a hole in the graph. Sorry about that. Please make the correction. Good. So then I was not able to simplify it. So then they will stay. If they stay, x equals negative 1 and x equals 1 are
Holes in the graph.
x plus 1 was simplified. Therefore, x equals negative 1 is not a vertical asymptote, but a hole in the graph.
So it's not a hole in the graph.
Very good. They're vertical asymptote. They could not be simplified. If they are simplified, they're a hole in the graph. They become a hole in the graph. But if they're not simplified, they have to stay, and they are vertical asymptotes. Good.
Are vertical asymptotes or horizontal asymptotes x equals?
No. Horizontal asymptote is a horizontal line. It's y equals. Vertical asymptote is a vertical line, which is x equals. Is that okay?
Yeah.
Good. Okay, so since we know that that's why they are vertical, right? That's why in the table they are vertical, so we know they signify vertical asymptotes. Otherwise, I would write it here. But this function cannot have a horizontal asymptote. It would have a slant, either like this or like this. Not horizontal. Good. So moving on, let's determine these limits right away. So I want limit as x approaches negative 1 from the left of x to the third over x plus 1, x minus 1. And then limit as x approaches negative 1 from the right of x to the third x plus 1, x minus 1. I know the answer, but I don't know the sign. Once I write here vertical asymptote, the answer has to be infinity. I don't have any discussion there, but I don't know the sign. Can anyone give us the sign with -1 from the left? Plug in, imagine that you plug in -1.1 in all these x values and tell me the sign. Or you can put the function in the calculator and plug it in the calculator. So I'm going to share the screen. Yes?
Would it be positive?
Say it again.
Would it be positive?
This is negative, this is negative, this is negative. So it must be 3 negatives. With -1 from the right, like -0.9, this is negative, this is positive, and this is negative. So then the sign is positive. So negative here, positive here. Now I have to determine left and right of 1. So which page am I on? 6. So limit as x approaches 1 from the left, from x cubed over x plus 1, x minus 1. And the last one, limit as x approaches 1 from the right, x cubed, x plus 1, x minus 1. We know it's infinity. I have no question there, but I don't know the sign. And the sign is very important. So 1 from the left means 0.9. Can you tell me the sign when you plug in 0.9? You don't have to calculate anything. We don't need the number. We just need the sign of the answer.
It's negative.
Excellent, indeed. Positive, positive, negative. Great job. And here, with 1 from the right?
Positive.
Very
Positive.
good. Positive, positive, positive. Well done. Good. Okay, now we need this. So we want limit from x to the third, but this time I'm going to keep it as x squared minus 1 as x approaches infinity. Let's start with negative infinity first. It doesn't matter. I'm going to write it here. X approaches negative infinity, x cubed, x squared minus 1. How do we start? How do we determine this limit?
Positive.
Say it again. Yes, plug it in. So what is where does the numerator go? When we plug in infinity, where does the numerator go?
Oh, 0.
Infinity to the third.
Goes to infinity.
Good. And where does the denominator go?
To infinity.
Very good. We love it. Why? We have some tool. What is that tool that we use in the infinity over infinity? Yes. So what do we do to the top? Yes. Awesome. Yes.
We x squared.
Excellent. The denominator.
And then over 2x.
Good. I'll simplify. And now I have limit as x approaches infinity from 3x over 2. What is the answer?
It would just be infinity.
Thank you very much. Good. This one, same thing, still infinity over infinity. So this is limit as x approaches negative infinity. The top is still 3x squared. The denominator is still 2x. We simplify one of them. And now where does this go?
Infinity. Negative infinity.
Very good. Good. I have to plug in 0. When we plug in 0 in this function, we get 0 over -1, which is 0. Finally, after all this work, we exhausted this line, but we haven't done anything here, and we haven't done anything here as well. Good. So let's find now the first derivative. I'm going to copy the function here. I have no choice but to use, I shouldn't say no choice, but I will use the quotient rule. Can anyone help with the quotient rule?
3x squared times x squared minus 1.
Very good, awesome. Times?
2x.
Awesome. Over x squared minus 1 squared. We always run a clean ship, so you know what I'm going to do next. When I say that, I know it sounds silly, but maybe it will trigger your memory. What will I have to do next? Factor out x squared. Do not multiply. So this is gone. 3x squared minus 3. So this is 2x to the fourth, so this is minus 2x squared. Because I factored out x squared. Everyone agrees so far? So x squared, and this is x squared minus 3 over x squared minus 1 squared. Can the first derivative be 0? Can anyone help? When can the first derivative be 0? Alex? Noor? Gabby?
Is it when x is 0? I don't know.
Okay. What else?
Would it be square root of 3?
Very good. So I have to write that x squared is 0. So I have two solutions, x equals 0. And then x squared equals 3, which gives us x equals the square root of 3 and x equals negative the square root of 3. The quantity is quadratic. I cannot just write one solution. I have to write two solutions. Okay, so we have 0 and positive and negative the square root of 3. Okay, I saw that, Nora. I'm going to remove you and then come back through your phone. Okay, so negative the square root of 3, 0, 0, and the square root of 3, 0. So we have 0, positive, and negative the square root of 3. Now, I have to determine the function value here and the function value here. So I have to plug them in. Okay? I will get the same but opposite answers because, again, this is an odd function. So 5, I think I'm on 7, isn't it? Yeah. So f of negative the square root of 3 and f of the square root of 3. The square root of 3 times is 3 the square root of 3 with minus over 9 minus 1. Not 9, but 3, sorry. Over 3 minus 1. And the other one is the same, but 3 the square root of 3 over 3 minus 1, which is 2. I have to approximate this a little bit. I mean, a little bit. I have to approximate it because I don't know what this means and how much it is. So 3 minus 2, 3 minus 1 is 2, but this is 3 the square root of 3. So I know I can use my, I can share my screen, but it's the same thing. This is just a number that I need to get. So negative 3 the square root of 3, and then divide by 2. So that's negative 2.6 and positive 2.6. So this is negative 2.6 and positive 2.6. Okay, at this point I have to find the sign of the first